So this is our video for Wednesday, April 1st, April Fool's Day, but no jokes around here. Our objective today is to prepare for our quiz on inverse matrices. So just kind of walking you through the week. On Monday, you learned what an inverse matrix was and how to find it. Yesterday, you learned how to use the inverse matrices to solve matrix equations. Today, we're going to have our quiz. Tomorrow we are going to get back into reviewing, simplifying, multiplying and dividing rational expressions, and on Friday we'll add and subtract rational expressions. So you had an assignment Monday and an assignment on Tuesday, and so I wanted you to have the opportunity to look at your answers. And so you can pause the video and grade your homework. We have 1 through 9 at the top, and then that were on the front of your worksheet, or the first page of your worksheet, and then we have the back answers here. So if you'll pause and grade your paper. Now remember that I will be opening the quiz after the Zoom session today. So at 10 o'clock, I'll open it up. But if you have questions over the homework, like if you missed problems, be sure and join me for Zoom between 9:30 and 10. I'll be glad to answer your questions and work any problems. And after that session closes, then I will open up the quiz. And remember to take good, clear pictures and email them to me, please. Now, one thing I do want to talk about in looking at some of your homework, some of you are using decimals in your matrices for your inverses. Be sure and leave them as fractions. Change these. Do not change these to decimals, but leave them as fractions when you are stating your inverse. All right, so that was Monday's work. So next we have Tuesday's answers. Let me get that where you can see it. So again, pause the video and check your answers. Now notice that I want to come back, and I'm going to work number 42 from page 199, and then I'm going to work number 37 from page 213. So on number 42, you were to solve for x, and you have 4712 multiplied by x, and then you're adding 27, negative 3, 4. So just like with a normal equation, we're going to get rid of the part that's added or subtracted first. So I'm going to subtract this 2, 7 matrix over to the other side, and make sure that you are subtracting. So these would cancel out. That's going to leave 4, 7, 1, 2, x. And then when I subtract here, 6 minus 2 is 4. 2 minus 7 is negative 5. Negative 2 minus negative 3 is 1. And 3 minus 4 is negative 1. Be careful with your subtracting. Negative 2 minus negative 3 is a positive 1. Now, we do not have matrix division, but we can find the inverse of our coefficient matrix. So I'm going to have 1 over 4 times 2 minus 7 times 1. On the inside, the 2 and the 4 are going to trade places. The 7 and the 1 become negatives. So on the outside, I'm going to have 8 minus 7, so I'm just getting 1 over 1. So when I distribute, my inverse is going to be 2, negative 7, negative 1, 4. And so to figure out the x, I'm going to take this inverse and I'm going to multiply it in front of the coefficient matrix, just like we worked on before spring break. We're going to take rows of the first by columns of the second. And remember that the inverse needs to go in front of the constant when you're multiplying. So row column, so I'm going to do 2 times 4 plus negative 7 times 1. 2 times negative 5 plus negative 7 times negative 1. Then I'm going to move to the second row. Negative 1 times 4 plus 4 times 1. Negative 1 times negative 5 plus 4 times negative 1. So here I'm going to have 8 minus 7 is 1. Negative 4 plus 4 is 0. On this side, I'm going to have negative 10 plus 7. So that's a negative 3. And here I'm going to have 5 minus 4, which is 1. And so the answer for x is 1, negative 3, 0, 1. On page 213, number 37 was a word problem. So the first thing you needed to do was to set up your equations and then solve. And the first sentence says that a rectangle is twice as long as it is wide. Twice as long as it is wide. So if it were 5 inches wide, the length would be 10. So the length is twice the width. And the perimeter is 840 feet. And so hopefully you remember your perimeter formula from when we were studying formulas for the ACT and the ACT Aspire. And if you haven't heard yet, we are not going to be taking the Aspire this year. I know some of you will be disappointed. I actually am disappointed because I was hoping to see how well you guys had grown. But that's something we don't have to worry about this year is the Aspire. All right, so I've got my two equations. L equals 2W, and 2W plus 2L equals 840. Now, the directions don't say that you have to use inverse matrices. So I first thought is just to do some substitution. This says L is equal to 2W. So this 2W right here can change to an L. And then I have 3L equals 840. So I'm using substitution from chapter 3. And when I divide by 3, I end up with 280, and the units were feet. And then I can just take the 280 and divide by 2, and my width would be 140 feet. Now it's not really cheating, but that's probably not the way that you guys thought about doing it. So if we were going to turn it into a matrix equation, the first thing we would have to do would be to get this equation in the same order as this one. And so I'm going to subtract the 2W over. I'm going to leave this equation. And if you have 2L plus 2W and L minus 2W, that's fine as well. And then right here, I would be tempted to do the elimination method. But if you're doing the matrices method, inverse matrices, you do negative 2, 1, 2, 2 for your coefficient matrix, W and L for your variable matrix, and 0 and 840 for your constant matrix. And then find the inverse of this matrix and multiply in front, and you'll end up with the same answers that you have over here. So what I'm trying to say is on a word problem, get your two equations, and then you can use other algebra methods from chapter 3 like substitution or elimination, or you can use the inverse matrices that you learned for this lesson. Now on the other problems, the non-word problems, I definitely want you to be solving using the inverse matrices. But on the word problems, I know a lot of you kind of get nervous about those, and so with the word problem on the quiz, you don't have to use inverse matrices. You can, but you can also use other algebraic methods. But on the other problems, I want you to be sure and use inverse matrices. So remember, Zoom from 9:30 to 10. I'll be live, and you can ask me any other questions that you have in preparation for the quiz, and I'll be opening the quiz up at 10 o'clock. Be sure and take good pictures and email them to me.